Guys, here we are back again. It's just math, y'all, and we are going to look at solving equations as an introductory aspect. So let's look at solving equations. This is going to be 2122. And in chapter 1, we did expressions and we simplified expressions. That's what we did at the end of chapter 1. And that was really important. Remember, we did the distributive property and then we combined like terms. And that was what we said was simplifying expressions. So chapter 2, we start with equations. And so first thing we need to know is what the difference is between an equation and an expression. This is important. The difference between equations and expression is an equal sign. An equal sign. Expressions do not have equal signs. If you'll look back at the ones that I gave you, there were no equal signs. Okay, an equation is actually two expressions set equal to each other. So now let's look at a couple of little examples. Okay, so these are expressions. All right, expressions would be like 3x plus 7 or 7 times 2n minus 9. These are expressions. Or 4x, that's an expression. It's a very simple expression, but it's still an expression. Or one that's a little more complicated, like 7 minus 3 times quantity n plus 2 plus another n. Those are all expressions. They don't have an equal sign. Okay, and now these are examples of equations. Equations would be something like 3x plus 7 equals 4x. Notice we took two of the expressions and set them equal to each other. Or another example might be 7 times 2n minus 9 equals 7 minus 3 times n plus 2 quantity plus n. And that would be an equation. It's got an equal sign. And it's very important that you pay attention to that equal sign. Okay? We simplify expressions. This is what we did in chapter 1. But once the expressions are simplified, then if there's an equation, we can solve an equation, okay, for the missing variable. So let's take the one we had before. This is an equation that's made out of two expressions set equal to each other. Now, I can simplify each side. I can simplify this side by using my distributive property. And that's it. That's as simple as I can get that one. Now, the one on the right side of the equal sign, this one's on the right, this one's on the left, and the one on the right is a lot more complicated. I have to do a lot more simplifying, but I can still simplify it just like I did before. And I would distribute this, and it would be a negative 3n minus 6, bring down the 7, bring down the n, combine like terms. Those two combine to make a 1. Those two combine to make a negative 2n. And so now I've simplified this one. And so once the two expressions are simplified, then we can start our solving. Okay? Before we start, we have to learn how to do it. Now we can solve these. We can solve for the missing variable. Okay, so let's look at the foundation of solving. All right, so now basically solving is kind of like a game. It's kind of like a game, and there are many different moves you can make, and then there's a strategy, and so this is kind of like a game. So not everybody will do every problem exactly the same way, but the idea is the same. The object of the game is to get the designated variable isolated on one side of the equal sign and everything else on the other side. Okay, and so that's the object of the game, to get the designated variable isolated on one side of the equal sign and everything else on the other side. So if your variable is x, that means make it look like this. Make it say x equals something or something equals x, if that's what your variable is. If your variable is n, then you would say make it n equal something and everything's over there and it's a number or other things, or something equals n. N by itself is isolated on one side of the equal sign and everything else is on the other. Okay, so now permissible moves. Now this is important. Again, like the games, there's certain things you can do and certain things you can't do. But when it comes to equations, it's the equality. Equal. Equal means the same. You have to treat everything the same. Okay? Whatever you do to one side of the equal sign, you must do to the other side of the equal sign. Now, this is kind of like equal. Equal means the same. If they're equal, you must treat them the same. Whatever you do to one side, you do to the other. This is the left side, and this is the right side. And whatever you do to the left, you also do to the right. Okay? You can add a number to the both sides. You can subtract a number to both sides as long as it's the same number. You can multiply the left side by a number. But you'd also have to turn around and multiply the right side by the exact same number. Same with division. Okay? There's lots of things that you can do as long as you do it to both sides equally. It's like children. I have to treat all my children equally. Okay? All right. So now, since there's a lot of permissible moves, I can add to both sides, I can subtract to both sides. Lots of permissible moves. So now we've got to decide what is an effective winning strategy. Okay, so what is it that's going to help me get my variable isolated? Well, that's the trick here. Choose your moves carefully. All right. Decide to reverse what happened to the designated variable. Okay, so we look at what happened to our variable and we choose to do the reverse. So if something was added to my variable, well, the reverse of adding is subtracting. If something multiplied to my variable, well, then I'm going to divide, do the reverse. And this is going to get it isolated. The idea of undoing. Undo what happened. So look at it. Hey, there's my variable. 6 was taken away from my variable, subtracted. So I better add 6 back. So now, that's not the only thing you can do, as long as you do it to both sides. You can also do something to an equation that creates an easier problem. You'll see this later on. Okay, so if I have a variable and variable was 4 was added to my variable, and then the result was 10. Now you can do this in your head. You should know that x is 6. But if I reverse what happened to my variable was had 4 added to it, so I'm going to take away 4. If I take away 4 from both sides, then I get x is 6, and I have isolated my variable. I have solved the equation. Okay, we'll do more of this in a little while. Okay, simplifying sides. Got to finish this one up. This video is getting a little long. I know how it is. All right, so simplifying sides. Remember, simplifying means removing parentheses using the distributive property, multiplying or dividing or combining like terms. This can all be done anytime it seems necessary, but we always want to do it before we start, and then watch out to see if it needs to be during the process. But we always want to simplify before we start, and then look to see if there's any other time that we can do that. Okay, because simplifying is not a both sides thing. It's just making it, whatever we have, a little more simple. Okay, so now the next video we're going to start with a ton of examples. So see you in the next video.